Good morning, Year 6. Welcome back to your maths lesson. So today is Tuesday, the 23rd of February. We're going to be continuing on with ratio for this week, okay? So I'll start to share my screen. So our learning objective today is to compare fractions and ratio. Your Fast Five is up on the screen now. So feel free to pause the video here, have a go at that, and then I will come back to you with the answers. Okay, 6, well done. So your answers are up on screen, or some of them are up on screen, and we will go through them. So number 1, what is 24,000 meters in kilometers? And your answer is 24,000 kilometers, 24 kilometers even, not 24,000 kilometers, 24 kilometers. So we should know that 1,000 meters is in 1 kilometer. So we're going to do 24,000 divided by 1,000, which gives us the answer of 24 kilometers. If you do need support in these types of questions, remember that you've got your conversion fact sheets given to you by Miss J last week, okay? So number 2, I bought a bottle containing 2 liters of water. After a long drink, I had 1,300 milliliters left. How much water did I drink? Give your answer in liters, okay? So don't forget that last bit. Give your answer in liters. We know that in 1 liter, there is 1,000 milliliters. So with having 1,300 milliliters left, we know that I've drank about 700 milliliters. Converting that into liters gives us 0.7 liters. Do not forget your units. That's for all of these questions. Don't forget your units. Number 3. So if 1 inch is approximately equal, remember that's our approximately equal sign, to 2.5 centimeters, then how many inches would be in 17.5 centimeters? So you can see up in the right-hand corner here, I have put up the method which we were using last week. And at the top, I've got my rule, my known fact. 1 inch is approximately equal to 2.5 centimeters. Now I want to know how many inches are in 17.5 centimeters. So I've put that down here. Now, to get from 2.5 to 17.5, we have to times by, not 5, we have to times by 7, okay? We have to times by 7. And what we do to one side, we have to do it to the other. So 1 times 7 gives us 7, okay? So our 7 inches is approximately equal to 17.5 centimeters. So if you got that, well done. I will highlight it red for you. Okay, number 4. If 72 pints is approximately equal to 9 gallons, how many pints would be in just 1 gallon? Okay, so now, given this new information, we've got to change our method. So up here, I'll put 72 pints. I'll put 72 pints is approximately equal to 9 gallons. 9 gallons, okay? And then we need to know how many pints are in 1 gallon. So I'll put my 1 gallon down at the bottom here. My 1 gallon down at the bottom here. And then pints, which is a number we are not sure of yet. This is the number we're trying to find out. So to get from 9 gallons to 1 gallon, we're not going to multiply this time. This time we're going to be dividing, okay? So I'll grab my division symbol from the corner. Here, we are going to be dividing. So obviously we divide 9 by 9 to get 1, so divide by 9. And then, of course, we know we've got to do it to both sides. So 72 divided by 9 gives us 8. Okay, so the answer is 8 pints is approximately equal to 1 gallon. Okay, so 8 is your answer. Well done if you've got that. Now, finally, number 5. Known fact, 5 miles is approximately equal to 8 kilometers, okay? So once again, I'm going to put that right at the top of my method. 5 miles is approximately equal to 8 kilometers. That's going to go right at the top. Two cars are driving on the motorway. Car A is driving at 75 miles an hour, and car B is driving at 115 kilometers an hour. Which car is going faster? Okay, so we know that we've got 2 different types of measurements that we need to convert the same so we can compare them. Okay, so what I'll do is I'll convert the 115 kilometers into miles. Okay, we don't need to worry about this per hour part. We just need to look at the relevant information. Okay, so we've got 5 miles is approximately equal to 8 kilometers. So let's change our information down here. We can put our kilometers and we can put our miles down here. And we know that car A is going at 75 miles per hour, 75 miles per hour. But how do we get from 5 to 75? Okay, so we could do 75 divided by 5, which gives us the answer of 15. Okay, we're going to be timesing 5 by 15 to get 75 miles an hour. And of course, we know that what we do to one side, we should be doing to the other side as well. So I'll copy this and I'll put it on the other side as well, which means we need to do 8 times by 15 to give us the amount of kilometers an hour. Okay, so we're going to do 8 times 15, 8 times 15, which is going to give us 120 kilometers. Okay, so we know that 75 miles an hour is the same as 120 kilometers an hour, and car B is only driving at 115 kilometers an hour. So we're able to say that car A is the car which is going fastest. Okay, car A. So well done if you got that right. So moving on to our big question. Okay, it's right here on screen. The ratio of red counters to blue counters is 1 to 2. What fraction of the counters is blue? Half, third, or 2/3? And what fraction of the counters is red? Okay, and you're given the same options. I'll put a little challenge there on the bottom if you want to challenge yourself. How many blue counters would I have if I had 4 red counters? Okay, have a think about that, but keep the big question in mind. Okay, so comparing fractions to ratio is not as simple as it looks. Okay, so we know that there are obviously 2 numbers in one format. Okay, but it is not the same. It's not a simple comparison. For example, the ratio 1 to 2 would not be the same as the fraction half. Okay, and the main difference is, the reason for this is, fractions tell us the amount apart out of a whole. Okay, but ratio tells us the proportion of one item compared to another. Okay, it's not part of a whole like a fraction is, it's one whole compared to another one. Okay, so let's go back to our big question to demonstrate. Okay, I've written at the top here as well, having the pictures or diagrams in front of you is a really helpful way of showing this difference. Okay, so you can see the ratio of red counters to blue counters is 1 to 2. So for every 1 red counter, there are 2 blue counters. But then we've got to ask ourselves, what fraction of the counters is blue? So to do this, we've got to count up all of our counters. How many counters are there altogether? There is 3. There is 3. And how does this help to work out the fraction? So if we've got 3 as our whole, we know that this is going to be the denominator of our fraction because it is the whole. Okay, it is the total amount. So we know that there are 3 counters altogether, making our denominator 3. Okay, let me just get the pen. So we know that our denominator is going to be at least 3. Sorry, this is a really stupid color. At least 3. So we know that our answer shouldn't be this number here. Okay, it shouldn't be this number here. So looking at our picture now, how does this help us to work out the fraction? So we're looking for what fraction of the counters is blue. Okay, and we've got 3 counters, 2 of them being blue. Okay, so our numerator is going to be 2 out of 3, which is our whole. So your answer is 2/3. Okay, now what fraction of the counters is red? Once again, we've got 3 counters, which is our whole. So we know our denominator is going to be 3. So we can cross this one out again. Now, how many of the counters are red out of this 3? 1 is. Okay, only 1 is red, which would make it our numerator. So 1/3 of our counters are red. And as you can see, neither of these are the same as the ratio, which is 1 to 2. For every 1 red counter, there are 2 blue counters. Okay, so the bar model is also another method that we can use to easily compare the two. Okay, so we've been using the bar model across lots of topics, and it can also be applied here. So let's consider this question together. There are some red and green cubes in a bag. 2/5 of the cubes are red. And now there are some true or false questions, okay? So given this information, straight away, we can start to build up a method to our question. So firstly, what does the denominator tell us, okay? What were we just discussing? The denominator tells us the whole, okay? So by knowing 2/5 of the cube are red, we know that 5 of these, there are 5 cubes in this bag, okay? And from that, we can create our bar model with 5 different equal parts, okay? Equal parts. And 2 of them are red. So we've drawn that in, 2 of them are red, which means the rest of them are going to be green, doesn't it? The rest of them are going to be green. So we can see our fractions a little bit more clearly now. So true or false? For every 2 red cubes, there are 5 green cubes. For every 2 red cubes, there are 5 green cubes. Now, we can look over straight our bar model to find out if this is true, okay? So we've got our 2 red cubes in our bar model. We've got our 2 red cubes, and it says there are 5 green cubes, but as we can see, we've only got 3. So we can tell straight away that this question is going to be false. And number 2, for every 2 red cubes, there are 3 green cubes, just as we counted, okay? So this one is true. Now, number 3, for every 3 green cubes, there are 2 red cubes. So once again, we'll go back to our bar model and we'll count up our green cubes. There are 3. And yes, for every 3 green cubes, there are 2. So once again, this one is true. And then we'll check our final question. For every 3 green cubes, there are 5 red cubes, which we know not to be true, okay? So drawing your bar model can be really helpful in representing these fractions out for you, and it can be a good way to compare the ratio. So let's do a bit of me and we. So this bar model shows the ratio 2:3:4. Now, what fraction of this bar is pink? Now, once again, we know that the denominator tells us the whole, okay? So the first thing that we can do is work out our denominator by counting up all of the parts. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, okay? So we've got 9. So we know that there are 9 overall, and we can put our line there. So what fraction of the bar is pink? We can see 2 out of the 9 are pink. So that's in answer to our first question. So I'll label it as A. And the second one is B. What fraction of the bar is yellow? Once again, we're going to put 9 as our denominator. 9 as our denominator. And we've got 3 yellow. So we'll put 3. And then C. What fraction of the bar is blue? We've got 4 out of our 9 are blue. Okay. And then I've got my key question just under here. Can you simplify any of your fractions? So we're going to look over our work. Can 2/9 be simplified? No, it can't. Can 3/9 be simplified? It can, okay? So we can divide by 3 on the top and the bottom. So 3 divided by 3 gives us 1, and 9 divided by 3 gives us 3. So we can simplify our fraction to 1/3. And then 4/9, we can't simplify, okay? We can't simplify, but here are our answers. So now on to we. 1/3 of the sweets in a box are mints, okay? The rest are chocolates. What is the ratio of mints to chocolates in the box, okay? So you can see, I've got the question, could you apply the bar model here? And yes, I've written the bar model up. So I've split it up into thirds. 1/3 of the sweets in a box are mints, okay? So I've got my bar model made up of 3 equal parts. And what I'll do now is give you a chance to pause the screen, continue from here, have a go, and then I'll come back to you with the answer, okay? Okay, 6, so I hope you had a good go at that. I'm going to put the answer up on screen now, okay? So you can see 1/3 of the sweets in a box are mints, okay? So I've underlined that, and I put an M in just one of our thirds. And the other 2, I've put C for chocolate, okay? So it said the rest are chocolates. And now we've got to find out what is the ratio of mints to chocolates in the box. Okay, so as we know, we can use our for every phrases to work out ratio. So for every 1 mint, there are 2 chocolates. Okay, for every 1 mint, there are 2 chocolates, which would make our ratio 1 to 2. Okay, so remember we say it 1 to 2. And if it was the ratio of chocolates to mints, it wouldn't be 1 to 2, it would be 2 chocolates to 1 mint. It would be for every 2 chocolates, there is 1 mint. Okay, so our answer is 1 to 2. So well done if you got that. So moving on to our U now, here is your question to have a go at. Ron plants flowers in a flower bed. For every 2 red roses, he plants 5 white roses. He says 2/5 of the roses are red. Is Ron correct? Okay, so remember to find your total, find your denominator, and then try and perhaps create a bar model to help you, okay? So have a go, and then I'll come back to you with the answers, year 6. Okay, well done. I'll reveal the answer to you now, okay? So I'll just straight up delete that. So Ron is incorrect because 2/7 of the roses are red. He has mistaken a part with the whole, okay? So he's put 2/5 of the roses are red. And by saying that, he said that his denominator, the total, is 5. When in reality, we know that Ron's planted for every 2 red roses, he's planted 5 white roses, which gives us a total of 7, which is why I split my bar model into 7. Okay, so he says for every 2 red roses, so I'll cover in my 2 red roses, he plants 5 white roses. Oh, I don't have a white color. Here we go. That's rubbish. I'm going to do them green. Okay. So here are his white roses. He plants 5, which is a total of 7. Okay. So he is right that it is 2 of the roses are red, but it is 2/7 of the roses are red, not 2/5. Okay, so well done if you got that. Well done if you've used your bar model. That is key in working out these questions. Okay, so have a think. What do we know about fractions and ratios so far? And once again, the bar model is once again a helpful method for us to remember. Okay, so have a think about that and your success criteria. Okay, so sorry, the learning objective's not there. So our success criteria is to identify the denominator, so you know the whole. Once you know the whole, you can then create your bar model and then use the bar model to help you work out the ratio using your for every sentences, okay? Don't forget those because they're very helpful. Okay, your for every sentences. So once again, your assignment is up on Teams for you to do. If you can't access this, email the year 6 and we'll send you the questions for today's lesson. Other than that, enjoy the quiz. I hope you do well and I look forward to hearing from you soon.